Yeah.
Number 5.
This 5?
Yeah.
Hydronic reactive field produces water according to the equation. If the rate of production is 1.34, what is the rate of oxygen gas consumption in moles per minute? So one of the things, this is back to one of the earlier things, is that stoichiometry applies to moles and rates as well. So because this is a moles per minute, you can apply stoichiometry. So if water is 1.34 moles per minute, how would you move it over to oxygen gas?
Divided by 2.
There you go.
Oh.
Yeah.
And how do I do this?
Following data is a pain, plot the data on the graph below. So you have to make your own little graph, and then have you plotted it?
Huh?
Have you plotted the data?
No, but like this stuff, like how am I supposed to know this? That's not common sense.
Oh, well, math.
Math? We don't get taught any of this in math class.
Rise over run, slope, equation of a line. Is that not taught in Math 10 anymore?
No. Like math 9 maybe, but why, how am I supposed to remember math 9 if you calc 12?
We are
How this works.
we are expecting you to know math in the senior sciences. But if you want to look up online for a brief tutorial, it'll be slope and y equals mx plus b would be helpful search terms.
Is this look good for my graphs?
Yeah.
I didn't know. I couldn't find how to put a title for the
There
y-axis. That
is a
okay?
way to put a title, or you could figure out a way to like put it
Do I
in your
need one?
document. Yeah, you need one.
Okay.
All axes must be labeled.
I do not know how to put one.
Yeah. There.
Two things.
Yep.
There was no table for part 3 and 4, so I can't put a class average.
Right. There is no class average for part 3 and 4.
Oh, okay.
Right. Crazy person.
Second thing,
Second thing.
on sheets, it's difficult to overlay two graphs to show
You
two
can-
separate things.
You can get sheets to do 2 graphs, but if you can't, you can put in just 2
Two
graphs.
graphs?
Yeah, that's
Okay.
fine. I don't mind that. Yeah.
So, just looking at the examples, you say you should include a table of the class and class average as well.
Mm-hmm.
Is this alright for how it is?
Yeah, that looks good.
Because I got average.
You got your average. You got your last times there.
Do we have inputs for these ones? Because I wasn't here.
For class averages, no.
No, it's just
No,
average.
it's just individual results.
Okay.
That graph is tiny though.
Yeah.
Like I'll never be able to
expand
read
it, yeah.
that. Okay.
So that's my data. Do you want a graph for mine and separate the class average?
I believe it asks you for that. Yeah.
Where
Is this
does it-
parts 1 or 2?
Huh? Those are all the parts. This is table
Okay.
1. this is table-
Yeah, you need to put titles in your
Yeah,
tables.
I know.
And then you need class data in your tables, your data and class data.
Mm-hmm.
And then I believe it asks. Da. 18, is this right one? No, it's not. It's 18A, that's fine. So, plot a graph of the results with a rate plotted against temperature. That's your data. Repeat these calculations using class averages and plot the results in the same graph.
Okay, so you have to make 2 graphs in the same.
Yeah, 2 lines.
Does that work in Excel?
In Excel? Oh, absolutely. Excel can do everything.
Sure.
Yeah. Excel is like, if Google Docs is a handy little calculator,
Mm-hmm.
Excel is a supercomputer.
Okay.
It can do everything. If you go to university, all they'll use is Excel because they need it to crunch
Okay,
their numbers.
so I just have
Yeah.
one table,
Yeah.
in that table my data
Yeah.
and the class
Yeah.
average, and then same with the graph my
Yeah.
data.
Yeah. Okay, it's almost 11:35. You could put away your lab for the last 10 minutes. We're just going to go over some potential energy diagrams for exo and endothermic reactions. Go over energy terms for those. Pull out your notes. All that stuff. Computers away, notes out. Computers away. Pardon? What do you mean if you keep it?
Like, let's say you take a test and then you have your quiz and you do better on your quiz.
Yeah.
Then does that count for more on that section?
Oh, it's in the homework pile. As long as it's helping you, I keep it. I'd run a test what your mark is with and without it on the quiz average, not individual quizzes because that's too hard. And if your average is helping you, if your mark is I just look at your mark. If it's higher with the quiz is in there, I just keep it.
So is the only thing that like October one gonna be on is like
If someone asked me for your mark right now, I would say it's too early to tell. If they pointed a gun at my head, I would tell them your quiz mark.
this quiz mark?
Yeah.
You get a gun.
Well, no, not that quiz mark. In about a couple hours, that quiz mark in your Chem 11 quiz.
So if our Chem 11 quiz cancels out this quiz?
Your Chem 11 quiz will be canceled by your first major Chemistry 12 test. ABC.
So, okay, so the Chem 11 one goes in there no matter what.
No, and I'll explain tonight because I want to get on with the notes, or just briefly after class. Come and see me. We did this while you were gone. Okay, your potential energy diagram. It doesn't really matter what numbers you used as long as their differences are the same. So I am going to use, if I backfill this, I'm going to say that this is at 20. That will make this 10 and that 0. This is in kilojoules. That will make this 30, that 40, 50, 60, oh, I'm running out of room, 70. I mean, it's a rough graph, so, and it's your notes, so as long as you can understand it. Yeah, my spacing isn't the greatest there. If this is an energy of activation of plus 30 kilojoules, what number from starting at 40 should I go up to? 70. So I need to make sure that I am all the way. Why is it not good? Come on. I hit this peak up here for my energy of activation. So this should go up and then it should come down. And that's a very weirdly sloping graph, but I'm going to keep it because I don't know how I draw it otherwise. So that is our energy of activation there. And this distance, if I just keep this going here, down to there, that is delta H is equal to negative 20 kilojoules. This is what makes this an exothermic reaction. Because as we know from last year, it dropped in energy. So that went from potential energy. Where'd that energy go? Ooh, it went into the environment. As what type of energy? Someone said ATP. That it could be if this is in a mitochondria. So we got plus 20 kilojoules to, someone said ATP. Sure. What else? Heat. Or any form of kinetic energy. So that energy was captured, went out, blew up, made a bang, drove a car engine, or captured as ATP, depending on the reaction. Now this reaction, I said we're going to make it, this is not probably ATP because we're putting something together.
Sorry, could you just restate what is the change in H mean again?
So this, I haven't defined it yet. I'm going to define it below. This is known as enthalpy. So delta means change in. And the brand new term is enthalpy. You can think of it as the energy in the bonds. When it drops, it's negative. To remember the term H, we often refer to it as heat, because when it drops, heat comes out of the equation. We get an explosion of some kind. And so the change in enthalpy is that the energy dropped by minus 2 kilojoules from reactants to products. Or products have 20 kilojoules less energy than reactants. So a main difference between chemistry 11 and chemistry 12, if you're doing these diagrams, is that now we put numbers in them. And reactions take a certain amount of energy. If something is exothermic, it is always negative, because it had to drop in energy from the beginning to the end. And the change in enthalpy is one of the forces in the universe that drives chemical reactions. Exothermic reactions tend to be spontaneous. Endothermic reactions tend to be non-spontaneous. There's one other force in the universe. We'll discuss that a little bit after. Now, if you drew this, it didn't matter if you were at 20 or at 40, as long as the drop was 20 and the energy of activation was 70. There's a lot of writing on there. Anybody not finished annotating? Good. Okay. Then I would like you here, I'm going to come around and take a look. I want you to make this one endothermic. I apparently got worse at writing. Endothermic. I want you to give me a delta H with an absolute value of 100 kilojoules, which means I'm not telling you the sign. I want you to figure it out on the graph. And an energy of activation of 150 kilojoules. Does everybody know what the absolute value means? Yeah, so I'm not telling you if this is, I'm going to take that away now. We are going to put either positive or negative in front of it, but knowing what you just learned, I want you to put the correct sign in front, positive or negative. So you're either going to put positive.
What is that?
Or you're going to put negative. And I'll make it bigger because I wrote the tiniest thing ever. 100 kilojoules. Is that visible from the back? Change that one. Yes, that's what I'm asking you. You have to decide. It's endothermic. Should it be a positive or a negative? And then draw that graph. And we just have like a minute and a half left, so I'll say tick it out the door. As soon as you show it to me, you can go. Need numbers. Other than that, looks good. Oh, that's oh, beautiful. That's.
So
That's-
20,
oh.
20,
Yeah.
from 20 to
Nice. Yep. I was just reading around. You're good. With the bell, you don't have to have numbers on it now. You just have to show me the right shape of the graph. That shape is good. That shape is good. Shape good. Gleb, your shape was good.
Feels like that.
Shape good. Yes, I was good. Writing was okay. Shape good.
Okay, I drew my graph bad, it looks pretty
Good. Did I see yours?
Yeah.
Show me shape of the graph.
It might be that.
Draw it
Looks
on it.
like that.
Okay.
It goes up. and
Okay.
then goes
Turn
down.
around and do it because I can't
Okay,
tell.
well, it goes up and then like that. and
Okay.
Like that.
Yeah, I have it, it's just my graph's bad.
Your graph is terrible, but that's the right shape.
I just did it.
Good.
Shut up, man. Shut up. I was trying to get equal line distribution, I messed it up.
And higher than expected.
Pardon? Okay.
Result goes in.
Here Friday, so do you want to take what I have now? I'm here Thursday.
Ooh,
but I'm not
you're not gonna do it between now and Thursday?
Well, were you planning on handing back on the Friday class, or did you
I
want to
wasn't
pick it up
planning on
right?
handing back on the Friday class.
Oh, then I can keep it on Thursday.
Yeah, and then you can put it in my mailbox. You can take the reception, but, and,
Can I just give it to you in class?
oh, yes, yeah, that works.
I'm just, I won't be here for Friday.
How much do I wanna see?
I'm using this as a.
Are you asking how badly or quantity?
Just wants it here.
I wanna see all of it.
Combine all that shit.
Well, because it's all in one book.
It's just up to the arrow.
Yeah, well, no, we're past the arrow now. We're on PLOP.
Okay.
Yeah.
So I have some questions.
So it's all due.
For that lab, like, how can I actually, because I'm really confused
Thank
about
you, Ron.
like how to organize my data and like I do really want to do well in this class, but it's really hard because I don't understand
Where were you in the tutorial?
tutorial. I was in another class
Which
because I was
class?
trying to catch up.
Which class?
Well, I went to physical geography because I was late on an assignment.
No, what I mean is you just got a physical chart. Doesn't matter. Never goes. Are you available this afternoon?
I volleyball from 2 to 4.
No.
Right at 4. Check on the server.
Where
Yep.
do I find them?
Do you have a number to text? And then I can just come do a door and say, and lead you to where my office is. So, my number.
I will not get caught.
And then just say, I'm here, and I'll make sure that I go to the right entrance. And bring you to upstairs. Are you in that guy? There's enough Mac people that are like, man.
Okay.
No, you said it. No. You said man.
What's that?
I feel ashamed.
I'm literally failing chemistry 12. I got a 6.2 on my test. What do you expect?
I'll see you at
I will see you at 4.